All right, let's look at the greatest common factor factoring method. This is very common factoring method that you'll see. So what is the greatest common factor? Well, the greatest common factor is considered the largest expression that is a factor of all of the terms in a polynomial. And so removing the greatest common factor is an important first step to factoring any polynomial later. So for example, if we have this polynomial, okay, here this is being represented in a more general form, we can see that this variable lowercase j, this represents our greatest common factor. And you can see that our greatest common factor is in each term in this polynomial. And when you factor this greatest common factor out of each term, then you can pull that out and place it outside the factored polynomial. And now if you were to go in reverse, then you would use the distributive property to redistribute this greatest common factor to every term in the polynomial. And then you're back to the original polynomial that you started with. So how do you go about factoring out this greatest common factor? Well, there's three basic steps. So step one is term expansion. So you want to expand each term into a product of factors. Step two is to record the greatest common factor. So for every factor that's common to all terms in the previous step, you want to cross it out and record it as a factor of the greatest common factor. Step three is to write the result, the greatest common factor times the factored expression. When no common factors remain, the factors in each term that are left will be the factored expression with the greatest common factor factored out. So let's look at an example of this, and we'll do a bit of an extreme example because I think the extreme example will demonstrate a little bit more about what the greatest common factor is. Okay. So here's our example. We want to factor out the greatest common factor. So given this polynomial, we can see we've got a polynomial here with three terms, right? Here's our first term, our second term, and our third term. So now I've just rewritten that polynomial right down here. And I apologize for these lines kind of moving around. All right, so first step is term expansion. So what we want to do is we want to take each term. So we'll take 60 x to the fourth y, and we'll expand that into all of its factors. So 60 is 2 times 2 times 3 times 5. X to the fourth is x times itself 4 times, and then times y. So we can see that the first term can be expanded into this product of factors down below. Okay, then we've got our second term here, and we can expand that into a product of factors. So 40 is going to be 2 times 2 times 2 times 5. X cubed is just x times itself 3 times. Y squared is y times itself twice. And then the third term in this polynomial, the coefficient 140 is 2 times 2 times 5 times 7. And then we've got x squared, which is just x times itself twice, times y times z. So that's step one. Step two is for every factor common to all terms, cross it out and record it as a factor of the greatest common factor. All right, so what does that mean? So what we want to do is we want to look at these three factored terms and find factors that are common in all three. So you'll see here that all three have a 2. So I'll cross that out, and I'm going to put a 2 right here. Okay, now are there any more? Well, each term also has a second 2. So I'll write that down here for the greatest common factor. Now, do all three terms have the factor 3 in it? They do not. So 3 is not going to be in the greatest common factor. How about a 5? Yeah, all three terms have the factor 5 in it. So I'll put a 5 in for the greatest common factor. How about an X? Yep, each term has an X. So I'll put another X down. Does each term have a second X? Yes, they do. So I'll put down my second X. Does every term have a third X? And not every term does. Okay, this one does, this one does, this one does not. Okay, so we cannot put down a third X for the greatest common factor. All right, so we're kind of out of options when it comes with X now. How about Y? Yeah, so every term does have a single Y. So we've got a Y, Y, and a Y. So we can put that down as our greatest common factor. Now, is there any other variable, any other factor that's common amongst all three? You know, okay, we haven't looked at Z yet, but this factor Z only exists in this third term. We don't see a Z in either of these other two. So that can't be a part of the greatest common factor. So the greatest common factor is going to be this product of 2 times 2 times 5 times x times y. So 2 times 2 is 4, 4 times 5 is 20, x times x is x squared, and then we got a y. So our greatest common factor is 20 x squared y. So that is step 2. Step 3 is now to write the result. So the result is going to be the greatest common factor times our factored expression. Well, the greatest common factor we figured out was 20x squared y. So there's our greatest common factor, and that's going to be multiplied by our factored expression. Well, what's our factored expression? Our factored expression is everything that's left. So you can see here we've got a 3x squared in the first term. So that's where this 3x squared comes from. Then in the second term, what do we have left? We've got a 2 and an x. Let me circle it. A 2, an x, and a y. So that's where 2xy comes from. And then finally, in the third term, we've got a 7 and a z. So that's where 7z comes from. So our factored expression is 3x squared plus 2xy plus 7z. So this is going to be the factored form of this original polynomial. We were able to factor out a 20x squared y out of every single term in this polynomial, and this is what we had left. Now, to check yourself, and we'll go at this at the very end, but to check yourself, you could just use the distributive property and multiply this 20x squared y times each term in this factored polynomial, and you should get this original polynomial out. That's how you check your work. Okay. So what I showed in a lot of detail here was how you go about finding the greatest common factor, which is composed of factors that are present in every term of a polynomial. Okay, with more experience, you'll be able to look at a polynomial and see that, well, it looks like 20 is going to be the highest factor of 60, 40, and 140, right? The coefficients in each term. And then you'll be able to look at the variables in each term and see, well, you can at least get an x squared out of each one, and you can get a single y out of each one. And then therefore, the greatest common factor is going to be 20 x squared y. So that'll be something that you'll be able to do without having to write everything down like this, but when you have more experience. Okay. So let's look at a few other examples here. So the first example is factor out the greatest common factor out of this polynomial. So the first thing we want to do is we want to write each term down as an expanded term, as a product of factors. So we're going to write 4x squared as 2 times 2, and then x times x. Right? This is 4x squared plus, and then with 8, we can write that as 2 times 2 times 2 times b times x. Okay, then we've got a minus 4, which we can write as 2 times 2, a times x, and I'm running out of space. Then we've got a negative 8 ab, so that's going to be minus. Okay, I'm running out of room. Let me redo this. Let me use more of the space that I've got. So I've got 2 times 2 times x plus 2 times 2 times 2 times b times x minus 2 times 2 times a times x minus, okay. Then an 8 is 3 2's multiplied times a times b. Okay, so that's step 1. Step 2 is now to find what the GCF is. So the greatest common factor is going to be where we can find a factor in every single term. So let's see, every single term has a single 2 in it. So we'll cross 1 out of each term. Okay, how about more? Can we get more 2's? Yep. So everyone has a second 2. So the greatest common factor will also have a second 2 in it. Now we're out of 2's. Okay, we can see that the second and the fourth term have a 2 in it, but the first and the third do not. So we don't have any more 2's that are common amongst all factors. So now we just move on to something else. So let's move on to x's. So we can see that we can't use an x, because even though there's an x in the first term, there's an x in the second term, there's an x in the third term, there is not an x in the fourth term. So x is not going to be a part of that. How about b? Well, b only appears to exist in the second term and in the fourth term, not across all. It's not common to all terms, so we can't do that. And how about a? Yeah, a only exists in the third term and in the fourth term, It's not common to all terms. So in this case, our greatest common factor is simply just going to be 4. And so now, step 3, if we were going to go into here and write this as the greatest common factor times our factored polynomial, then we're going to write this as 4 times, and let's see, what do we have left? Well, in this first term, we have x times x, then we've got 2 times b times x, then we have a times x, and we have 2 times ab. So the first term, x times x, is x squared. Then the second term, we have plus 2bx. Then we've got minus, and all we have left is ax. And then we've got minus again, and all we have left is 2ab. So this would be the factored form of this original polynomial that we had, that we started from. Okay, so let's stop this video here. The think pair shares that come next, these are ones that you're supposed to work on. So try these out yourself and see if you get the resulting answers that I've put down here down below. All right. And I guess what we'll do is let's skip on down to the end here and go ahead and show you that the greatest common factor can also be an expression. So an expression is going to be, like 2 or more terms. Okay. So what do we mean by that? So if we look at this example where we've got 4x times x minus 2 minus 5y times x minus 2. Notice that this first expression and this second expression, or this first term and the second term, both have an x minus 2 in it. So what this means is we can factor out this x minus 2 out of each term. And when we do that, what do we have left? We have 4x minus 5y. So if we started with this, this would end up being a polynomial here. But if we started with this expression that we've got up above, we could factor out this x minus 2, and this x minus 2 becomes the greatest common factor between both of these expressions, or both of these terms. And what we have left is just 4x minus 5y. So this is an equivalent form to what we started with here. And I've got a little bit more, what looks like a more complicated example. So what we have here is we have like a somewhat factored polynomial here where each term has x squared minus 1 in it. So if we factored out this x squared minus 1 out of each term, that becomes our greatest common factor. And what we have left is going to be x minus 5 plus 2x plus 7 minus x minus 6. All right, and then what we would do next is then simplify what we've got here. But this is how you can use just this simple greatest common factor, in even more advanced looking polynomials or expressions. All right, so let's stop this video here. So I've kind of shown at length the 3 steps, how to do them in a more complicated example. So, it's kind of on you right now to try and do this think, pair, share with these 3 and check your answers. All right, let me know if you have any questions.